Hi guys, last week we were analysing and solving division problems and using shading when we were trying to find out what each part was worth, and grouping when we were trying to determine the number of parts that we had. This week we're using exactly the same bar model, but we'll be trying to work out the whole amount, so we'll be using multiplication. To begin with, let's consider what this word multiply or multiplication actually means. So you might want to pause the video for a couple of minutes just to discuss your thoughts as a class. Quite often when I ask that question, I get an answer of, it means times, and people make this symbol, they make an X. And when I ask the question, well, what does that mean? It can be a bit confusing because time surely is to do with clocks and watches and what time of day it is and when's dinner and are we there yet? But here it means something different. To explain what I think this word multiply means, I'm going to use an example from a film that I saw when I was about 8 or 9 years old, and that film was The Gremlins. And in The Gremlins, a boy gets a Christmas present from his dad. He gets a cute creature called a mogwai. Now, when he gets this creature, he's given different rules, but one of the rules is that he's not to let water near it. He can't get it wet, because if he gets it wet, it will multiply. So what actually happens to this mogwai when it multiplies? Does it get any bigger? No, it doesn't grow in size. Does it split into lots of little mogwais? No, it doesn't. It doesn't divide into smaller parts. What happens is it duplicates. We get exactly the same again and again. So when something multiplies, we get a duplicate. If we multiply something by 5, for example, then that means we have 5 of whatever that thing is. Now, when we apply that to numbers, that means that when we multiply, we get the same again and again. To begin with, let's get thinking. I want you to consider the following statement, and I want you to discuss whether you think it's true or false. But remember, I don't want you just to say that's true or that's false. I want you to give reasons. I want you to justify why you think that. So here's the statement. It is important to memorise all of the times tables facts. So pause the video for a couple of minutes and discuss your thoughts with a partner and share those with the class. I wonder what your thoughts were in that. When I think about the times tables and what I had to learn when I was at school, we had to learn 12 times tables. So there they are there. And you can see altogether, that's 144 facts that I had to try to memorise. I don't have the best memory in the world. I can't remember what I did last Saturday, so the chances of me being able to memorise 144 facts are pretty slim. But when it comes to multiplication, what's important? Is it important that we memorise facts, or is it important that we understand? Let's consider another statement. If you can memorise the French national anthem, then you understand it. Is that true or false? I could sit and memorise that national anthem for weeks so that I know it word for word. But I still don't understand what any of those words mean. So actually, being able to memorise something doesn't necessarily mean you understand it. I don't understand the French national anthem, and I can't speak French. When it comes to multiplication, I don't want you just to be able to memorise some facts. I want you to be able to understand it so that you can apply that understanding to much bigger numbers. Because unfortunately, numbers don't stop at 12, which means we need to be able to work out what 5 times 17 is, or 7 times 234. And if we understand multiplication, then we'll be able to do that, not simply by relying on facts that we memorise. Let's have a think about the following problem. Iron Man has 3 bags of cookies. There are 4 cookies in each bag. How many cookies does Iron Man have altogether? Now, I don't want you just to solve this. I want you to think about how you're working it out. Okay, so let's have a think about how we might solve this problem. And to begin with, I know that I have got some cookies. So I'm going to draw a bar to represent all of those cookies. I know that I'm looking for the total cookies. I'm looking for the whole amount. How many parts am I going to split that bar into? Well, I know there are 3 bags. So let's split that into 3 parts. And how many are there in each part? Well, I know I've got 4 cookies in each bag. So let's put 4 cookies in each of those. And now what I want to do is work out how many there are altogether. Now what I could do to begin with is I could just count up all those cookies. So let's use a number line to just show what I'm doing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So all I've done there is just count up all the cookies that are in the 3 bags. Now that took me a little bit of time to do that, so let's think, could we do that in an easier way? So we've still got our 3 bags, only this time if I want to count up those cookies, I don't need to count them one at a time. I might count 4, and then another 4 to get 8, and then another 4 to get 12. I've still counted up all the cookies, I've just done it in 3 jumps or in 3 counts rather than in 12. Rather than keeping those cookies in the bags, it might be helpful to lay them out in rows. So you can see there we've got 1 row of 4, 2 rows of 4, and 3 rows of 4. And altogether I can add them up to get 12 cookies. You might wonder, why has he put them out in equal rows? And actually, this is going to help us with all multiplication, because when we organise them into equal rows, we make a rectangular shape that we call an array. Arrays are really useful for helping us to understand multiplication, make connections between multiplication stories, and allow us to multiply much larger numbers in the future. Let's use those cookies to help us have a look at the 4 times table. Now, let's not worry too much about that word times. Let's set out our cookies in equal rows. We're going to make an array. So there you can see we've got 1 row of 4, 2 rows of 4, and so on all the way down to 12 rows of 4. So we've got an array there that is 12 rows and there's 4 cookies in each row. And what we want to know is how many are there in 1 row, how many in 2 rows, 3 rows, and so on. So let's begin with what I think are the easy ones to start with. Now I think it's easy to work out how many there are in 1 row. So in 1 row of 4, you can see there we've got 4 cookies. What about 2 rows of 4? Well, in 2 rows I've just got 4 and 4, so I've got 8 cookies altogether. We're going to jump on and we're going to go to 10 rows of 4. And in 10 rows of 4, I know I've got 40 cookies altogether. And then the next one that I think is easy is 5 rows of 4. And in 5 rows of 4, I've got 20 cookies altogether. So what I'm going to do is I'm going to highlight those because they are going to be useful to help us work out the others. Let's look at 3 rows of 4. Now for 3 rows of 4, I could add 4 and 4 and 4 to get 12. Or I can see there that actually I've got 2 rows of 4 plus an extra row of 4. So I can just add 8, add 4 to get 12. What about 4 rows of 4? Now in 4 rows of 4, again, I could add 4, 8, 12, 16. I'm going through them 1 row at a time. But I can also see, well, I could add 2 rows of 4 plus another 2 rows of 4. So I've got 8 plus 8. What about 6 rows of 4? Well, again, I could go through it 1 at a time. It's taking me longer and longer each time I do this. 4, 8, 12, 16, 20, 24. But I can also see that in 5 rows I've got 20 cookies and I'm just adding an extra 4. So I can start at 20 and add 4 to get 24. What about 7 rows? Again, I could go through them 4 at a time, but that's going to take me quite a while. I can also see that I've got 5 rows plus another 2 rows. Now I know 5 rows is 20, I know 2 rows is 8, which means I'm adding 20 and 8 to get 28. What about 8 rows? Now, for 8 rows, let's start with 2 rows, because I know them, that's 8 cookies. If I double 2 rows, I get 4 rows, so I'm doubling 8 to get 16. And if I double 4 rows, I get 8 rows, so I can double 16 to get 32. What about 9 rows of 4? Well, for 9 rows of 4, I can see that that's 1 row less than 10 rows of 4. So I could start with my 10 rows and then I'm just taking away 4. So I've got 40, take away 4 to give me 36. What about 11 rows of 4? Well, 11 rows is just 1 more than 10 rows. 10 rows is 40, 1 row is 4, so I'm adding 40 and 4 to get 44. And then for 12 rows, again, that's just 2 more rows than 10. So we've got the 10 rows plus the 2 rows. We've got 40 plus 8 to get 48. I do not need to go through that 4 at a time if I've forgotten it. I don't need to count up 4, 8, 12, 16, and so on, all the way up to 48. Rather than writing rows of cookies each time, then in maths we use symbols to represent that. We use the multiplication sign. So that's where this x comes from. So we can write each of those facts using the multiplication sign. So there we've got there, and once again I'm going to highlight 1 times 4, 2 times 4, 10 times 4 and 5 times 4 because they're the really useful ones that we can use to help us work out the others. It's time to get investigating with a partner. Here we've got Captain Marvel, who's got 3 bags that each contain 7 sweets. She's trying to work out how many sweets she has altogether, and she's been asked to use resources and draw pictures to represent this problem. Can you help her? So, as with all problems, the most important thing is that you can explain your thinking, you can explain the strategy you use to work it out. You could use a bar to help you analyse this problem. You could draw the sweets and bags themselves. You might want to use a number line to help you record how you're working out the total number of sweets that she's got. So I want you to pause the video for 8 to 10 minutes, work with a partner, use the resources and draw pictures to explain your thinking. And if you finish before the time, then what if there were 7 bags with 8 sweets in each bag? Let's have a look at how we might work this out. So to begin with, I'm going to draw my bar, and that bar represents the whole amount. Now in this case, the whole amount is the total sweets that Captain Marvel has. Now we can decide how many parts we're going to split it into. Now there are 3 bags of sweets, so let's split our bar into 3 parts. And now we can describe what each part is. Well, each part is just the number of sweets in one bag. We know that there's 7 in each bag. What we're trying to work out in this case is how many sweets there are altogether. So you can see there, we know the value of each part. We know there's 7 in each, so let's put 7 sweets in each of those bags, and we know there are 3 bags. So all we're trying to do is work out how many sweets there are there altogether. Now we could count those up one at a time, and I'm going to use a number line just to record what I'm counting. So let's start with 0. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So there are 21 sweets altogether. Now that took a little bit of time counting those one at a time. Is there an easier way? Is there a more efficient way that we can do that? Let's start again. And this time, rather than counting them one at a time, I know there are 7 in that first bag. So let's put out those 7, and I can record that in my number line. I'm jumping on 7. I know there's 7 in the next bag, so let's lay that out again. We're using an array here. We're organising them into equal rows, and I know 7 add 7 is 14. And then let's put out our third row. I add 7 to get 21. Now I might have done that by adding 6 and then 1 to make it easier for myself. But I can see there I'm adding 7, add 7, add 7 to get 21. Is there another way we could do that? Well, I might know that 2 lots of 7 is 14. So rather than counting up the first row and then the second row, I can put those together. So 2 lots of 7 are 14, so I'm adding on 14. And then that third row, add on 7 to get to 21. So rather than doing it in 3 steps, I've done it in 2 steps. I've used the fact that I already know. I don't actually need to count on 7 at a time. I could use an easier number to start with. So rather than taking all 7 sweets from that first bag, I might take 5 of them. So there's 5 sweets. Let's take 5 from the second bag. That's 10 sweets. 5 from the third bag. That's now 15 sweets. And I've got 2 left in each of those bags. So let's add on 2 to get to 17, another 2 to get to 19, and another 2 to get to 21. I can really add up those sweets in any order I want. It's about being able to look at that and decide what's the easiest way for me to do this. I'd like you to think about our success criteria now, so pause the video for a couple of minutes and consider, how did we achieve success? What were the steps that we went through in order to analyse and solve that problem so that we can then use that success criteria and apply it to any multiplication problem? So let's have a think about the steps that we went through in order to achieve success here. And as with all the problems we've looked at so far, the first thing we can do when we're analysing a problem is draw the bar. And when we draw the bar, that bar represents the whole amount. So the next thing we can do is describe that whole amount. And in this case, the whole amount was the total sweets that Captain Marvel had. After that, we can then decide how many parts are we going to split this bar into. Now, we knew that there were 3 bags of sweets that each contained the same amount, so we can split this bar into 3 equal parts. Once we've done that, we can describe what those parts are, and in this case, each of those parts is the sweets in one bag. And then we can write the values we know. So here we know that there are 7 sweets in each bag. So we put those 7 sweets in each of those bags, and what we were trying to work out was the whole amount. So now that we can see that, the next thing we do is decide what strategy we're going to choose. We can then apply that strategy, and we worked out in different ways that there were 21 sweets altogether. It's time to apply that success criteria that we've just looked at to the following problems. Once again, we've got 3 problems, each with 3 levels of challenge, and I want you to choose the level of challenge that's just right for you. Not too difficult and not too easy. So if I'm looking at the first question and I decide I'm going to do a mild question, then I read this as, Captain America has 3 boxes of pencils. There are 3 in each box. How many pencils are there altogether? Question 2, I'm going to try the spicy this time. Black Widow has 6 packs of football cards. There are 6 stickers in each pack. How many cards does Black Widow have altogether? And then question 3, I'm going to have a look at the extra hot. Nick Fury has 8 boxes of cakes. There are 13 cakes in each box. How many cakes does he have altogether? Once again, I'd like you to explain how you're working this out. So use the resources to help you. Can you analyse by drawing the bar? Can you draw pictures, use number lines to explain that thinking? If you finish that in the time, then I want you to make up 3 problems for someone else to analyse and solve at your group. So pause the video for 10 minutes or so and have a go at those. It's time to reflect on our learning again this week, so pause the video for a few minutes and consider the following questions. What have you learned today? What did you find easy or difficult? Did you get stuck? What helped you when something got tricky? What do you need more help with? What is really making you think? And what are your next steps? The last thing I'm going to ask you today is, can you apply what we've learned? So as a class, I want you to discuss the following problem. Can you analyse it together? Can you solve it together? A minibus holds 13 passengers. What is the total number of passengers that can travel on 4 buses? And once you've had a go at that, you might want to have a go at, what if a bus held 15 passengers? How many passengers would there be altogether then? Thanks for taking part today. Hopefully you found that useful. Remember, if you've got any questions or you want to share any of today's solutions, you can email me at scott.morrow@south-ayrshire.gov.uk. You can find my weekly maths challenges if you follow me on Twitter at scottmorrowsa, and you can find all my lessons on video at my YouTube channel, Scott Morrow Maths. Next week we're going to focus on something different. We're looking at fractions and we're looking at identifying and creating fractions. So I hope you can join me then.